Greetings, class. This is Mrs. Lyons. This short video will hopefully explain the trend of ionization energy. So first, we have to define ionization energy as the energy required to remove one valence electron from an atom. Typically, this is done in the gas phase. All right. This trend, the period trend of ionization energy, is going to increase. I'm trying to highlight that, as we go from left to right across a period. So, for example, if we are looking at lithium, carbon, fluorine, neon, neon would have the highest ionization energy, and lithium in that period would have the lowest. So let's kind of look at the why. Why would that be? Okay, so let's think about what's happening as we're moving across a period. We've already talked about this, but I'm going to just kind of restate it, reinforce it. So some things that we know. Okay, we know that as we move across the period, each atom gains one additional electron. Okay, so the nucleus is becoming more positive. We also know that as we go across, each atom has its valence electrons in the same energy level. Okay, so all of the valence electrons for atoms in the same energy level are in the same valence shell. Okay, that means they're the same distance from the nucleus. What that means is that they feel that pull from the nucleus the same. Okay, whether there's one electron or 6 electrons, they feel the nucleus the same. Okay, so as we go from left to right, okay, so for example, neon has a much more positive nucleus. Okay, so it can pull on its valence electrons much stronger. Okay, the stronger the pull, the harder it's going to be to remove one valence electron. And when we say the harder it's going to be, what that means is it's going to take more energy. Okay, and the other thing that we know, we learned this last semester, is that neon is very stable because it has a full octet. Fluorine is almost stable. It's got 7 valence electrons. It does not want to give up an electron. In fact, it really wants to gain an electron. So the closer an atom is to having its outer shell full and reaching that stable state, the less it wants to give up an electron, which means the higher the energy is going to be to remove an electron. Okay, so as we get closer to having a full valence shell, the energy required to remove that last electron increases. Okay, so now we're going to look at the trend as we go, as we go down a group. Okay, so we've got lithium and sodium here, and the trend is ionization energy decreases as we go down a group. Okay, so what that's saying is that it takes less energy to remove this electron from sodium than it does to remove this electron from lithium. Okay, so same thing that we've talked about before. Lithium has 1 valence electron in its second energy level. Sodium has 1 valence electron in its third energy level. So in this case, we talked about that shielding, and that shielding effect really comes into play here, especially as we move farther down the periodic table. Okay, as we move farther down a group, the electrons between the nucleus and that valence electron shield the positive charge of the nucleus, and that valence electron can't feel it. Okay, and what that means is it's going to take a lot less energy to pull that electron off. Okay, so less ionization energy. Okay, so the same idea, the more energy levels, the more shielding, the less the electron feels the positive attraction from the proton, the less energy it takes to remove that valence electron. So I hope this has helped to explain ionization energy a little bit more. It increases as you go left to right across a period, and it decreases from top to bottom down a group. The one thing that I remember that helps me remember fluorine is actually helium is the element with the highest ionization energy. All right. Have a great day wherever you are, and I will see you in class.